So I made an executive decision, and I didn't do it lightly. I am going to put CNC motors or stepper motors on my manual mill. Now, I'm also going to do it so I can keep it manual. So the stepper motors will drive it when I want to use them, and if I don't, I can still use the mill as is. It's possible. I've seen other people do it. And, I'm not looking so much for an actual super high precision CNC machine. What I'm looking for is automation. Again, I know in one of my other videos I was talking about my up-and-coming CNC mill project, and that will be a bona fide high precision, hopefully 4-axis CNC milling machine. But the steppers for this are basically just going to be for facing and, let's say semi-precision stuff. Like if I want to put holes in a plate, rather than use my DRO, because what I think I might actually do is move the DRO I have that over to my lathe, because I'd like to have a DRO on my manual lathe. I don't have one right now, and after pricing them out I realized how ridiculously expensive they are. So anyway, stay tuned. So the plan at the moment is going to be replace this part right here. As you could tell, this and this are separate, and this are separate. This handle over here is off of this side, I'm guessing. I mean, this is how I got this machine. When you put this on, so what I'm gonna do is ignore this piece here. This is another one of my failed projects. What I'm gonna do is make this shape here into the back of a pulley, so I can have the stepper motor over here or over here, wherever, and it'll be belt driven. Like I said, I don't know if I want to do direct drive. I could use the double-ended stepper motor like I have on my lathe. Hang on, I'll show you. Basically, this is what I got on my lathe. It enables you to use it as a manual machine as well. I have it on both X and Z axes, so don't have to have the computer attached if I just want to throw something in real quick and turn it. So I could go direct drive, but my concern is the stick out of the motor. This is a NEMA 23. It has way more than enough torque for this lathe. But I don't know if this would be big enough for my mill. Probably looking at something like this. This is a 425 ounce of torque NEMA 23 stepper. Now this does not have the double output, so I don't have any that are this size, so I would have to buy 2 new steppers. But my concern is if I mount this, here, this is sticking out pretty far. I mean, I'll essentially be out here making my adjustments, and over here be the same thing. I mean, Not that I do it that often anyway, because I'm usually using the power feed. But that's why I think I'm going to do belt drive instead. It's not going to be as accurate. But like I said, I'm not going for super accurate. I mean, I want it as accurate as possible. Don't get me wrong. I mean, of course. But I might have to sacrifice a little accuracy for feasibility. Alright, let me show you what I got. This is the mount that I'm considering making. I'm still in the midst of modifying and, you know, fine-tuning, but this is the mount. Basically, if you get rid of this, get rid of the stepper, get rid of the shaft, and what you have here is the part of the machine that's coming out, you know, with the shaft. Now, if you add my two pieces, which will be one piece, get rid of the machine part, this is essentially what my part will look like. Stepper motor will go on the back side. Shaft will go, there will be a coupling connecting these two. I left the top open so I can get to the coupling and the shaft. And again, this is the machine. I think I'm really close to this, and I think I'm going to 3D print this and see how it does, and then from there I'll know if I should fabricate it out of steel or aluminum, whichever way I go. Anyway, we'll see what happens. Alright, I 3D printed this part here. I made it in CAD. I mean, it's not identical, but it's pretty darn close. And I did that because I want to be able to make the stepper motor mount without taking everything apart, because this project is going to take a little bit of time. So I don't want my mill to go down for a couple of weeks. So yeah, that's what I did anyway. You've seen the pictures of the mount that I'm making for the motor. Again, it's just a prototype, but I don't know what the final is going to be just yet. I'm guessing it's going to be some kind of a U-bracket type of thing. I mean, heck, who knows? Maybe even U-channel itself could work. We'll see. But, alright. We'll be back. I think this is the final revision. See the coupling. This is the shaft that connects to the machine. And then my stepper motor. I open these up for the hardware. I don't think it'll be a problem here since these are cap screws, but I did it here too just in case. "27 hours into this. Fortunately, we got a little bit of stringiness but this is 100% infill. I built it for rigidity. This stuff here is all going to be knocked out. Almost done. Alright, let me show you where I'm at. I made this. This is basically a mimic of this. Okay. Now, I made this. This, try and do this the best I can with one hand, will fit like this. So, exactly like that. And then, stepper motor back here. Now again, this is not the proper stepper motor, because the proper stepper motor will have a double-ended shaft for a handle. But this is the idea. Now I will bolt this up, and when I do so, if I did everything correctly, everything should be dead centered. It should be, again. There's a lot of ifs in there, but you know, this is the plan at the moment. Again, things can change. I don't know. We'll see. The other idea was to do a belt drive, which I don't want to if I don't have to, but if I do, I will. I might not even need this big of a motor. After turning these handles, they actually turn pretty easy. I mean, I could do it with one finger. So I might be able to get away with a smaller NEMA motor, which means I could use the ones like my lathe has, which would really stick out a lot less and, you know, make me feel a little warmer and fuzzier. So the only problem now that I can foresee is going to be the coupling, which is going to tie the stepper motor to the shaft. And the reason it's a problem is because this shaft is 17 millimeter and this is 10 millimeter. All of the couplings I have are nowhere near that size. In fact, I don't even know if I could get a coupling like I have in that size. I might have to change the design to one of those Lovejoy or whatever they're called connectors. I'll show you the other connector I'm talking about. I think I've already done this, but this is the connector here. Basically, you see those slots in there. It's designed for a little wiggle room, so if it's not completely centered, it stays rigid, but yet it allows you some flexibility. I'm not sure if I have a Lovejoy around here. Let me take a peek. I've got one somewhere, but it's escaping me at the moment. If I find it, I'll put it on. Anyway, let's start getting this bad boy together.